So, hello students, welcome back to our online class. Today we will continue with what we have started in the last class, that is exercise 7A of your textbook, page 217. Now, question number 2.1 of exercise 7A says, find all the possible values of A when the distance between 3, A and 4, 1 is square root of 10 units. To start with the solution, we write the given points are, first point is, we name it as A, 3, A, and the second given point as B, 4, 1. Now here, your x1 is 3 and your y1 is A. Your x2 is 4 and your y2 is 1. Now according to the question, the distance between these 2 points is square root of 10. So therefore, the distance AB is square root of 10. Now the distance AB, we use the distance formula, that is square root of x2 minus x1 whole thing square plus y2 minus y1 whole thing square. It is equal to square root of 10 as given in the question. Now squaring both sides of the equation, we have, see, if you square both sides of the equation, this sign, square root sign, and this square root sign gets cancelled. So we are left with whatever is inside this square root sign, that is square root x squared minus x1 whole thing square plus y2 minus y1 whole thing square, and here we are left with 10. Now putting the values of x2 as given in your question, since your x2 is 4, so we put here 4 minus your x1 is 3, so we put here 3 whole thing square, plus your y2 is 1, so we put here 1 minus your y1 is A, so we put here A whole thing square. It is equal to 10. Now 4 minus 3 is 1, so we have here 1 square plus 1 minus A whole thing square. It is equal to 10. Now in the next line we have 1 square is 1. But here we have 1 minus A whole thing square. This is in the form of A minus B whole thing square. As we all know that A minus B whole thing square gives you A square minus twice AB plus B square. So we expand this linear polynomial, we get this 1 squared, that means A squared is 1, so we get here 1 minus 2AB, that is 2 into A into 1, again we get 2A plus, now B squared we get here A squared minus, now this 10 here, which is on the right hand side, we transfer it to the left hand side. Since this is plus, so if it comes this side, it becomes minus, so minus 10. It is equal to, since 10 has already been transferred to the left hand side, we are left here with 0. This implies that by writing this in standard form, we write first the A squared this side minus 2A minus. Now these numerals, 1 plus 1 is 2, and here we have minus 10. So 2 minus 10, we have minus 8, so we write here minus 8. It is equal to 0. Now this is a linear polynomial, so we have to factorize this by splitting the middle term. Now factorizing this, we have A squared minus, since 4 into 2 is 8, and minus 4A plus 2A, we get minus 2A. So the middle term we write as minus 4A plus 2A minus 8 equal to 0. Now between the first term and the second term, we find that A is common. So we take A common, we are left with A minus 4 plus the third and the fourth term, 2 is common. So we take 2 common, we are left with A minus 4. It is equal to 0. Again, in the next line, we have a minus 4, which is common. So we take common. We are left with a plus 2 equal to 0. So either this a minus 4 is equal to 0 or this a plus 2 is equal to 0. So from here, we get a equal to 4. Since minus 4, if it goes this side, it becomes plus 4. And from here, a is equal to minus 2. Since plus 2, if it comes this side, it becomes minus 2. So there are two possible values of a as per the questions. One is a equal to 4 or the other a is equal to minus 2. Now let us come to the third question of your textbook, exercise 7a, which says, if a point a 0, 2 is equidistant from the point b 3, p and c p, 5, then find the value of p. Now for solution, we write the given points. That is, the given points are a 0, 2 as given, b is 3, p as given, and c is p, 5. Now here, to understand the question, since this a is equidistant from b and a is equidistant from c, means from a to b and from a to c, they are equal. So here for AB from A to B, your x1 is 0 and your y1 is 2, your x2 is 3 and your y2 is p. Now for A to C, means from A to C, again your x1 is 0, your y1 is 2, whereas your x2 here is p and your y2 is 5. Now according to the questions, we have from A to B, it is equal to from A to C. So the distance between AB, by using the distance formula, we have square root of x2 minus x1 whole thing square plus y2 minus y1 whole thing square. Now for AB, your x2 is 3 and your x1 is 0 whole thing square plus your y2 is p and your y1 is 2, so p minus 2 whole thing square. It is equal to square root of, for the distance between A to C, your x2 is 5, your x2 here is p and your x1 is 0 whole thing square plus your y2 is 5 minus your y1 is 2 whole thing square. Now squaring both sides of the equation, as we have done in the earlier question, this square root and this square root gets cancelled, square root sign gets cancelled, so therefore we are left with whatever is inside the square root, that is 3 minus 0 whole thing square plus p minus 2 whole thing square is equal to p minus 0 whole thing square plus 5 minus 2 whole thing square. It means the square root sign is no more. In the next line, we have here 3 minus 0 is 3, so we have here 3 square plus, again here, p minus 2 whole thing square. This is again in the form of a minus b whole thing square, so we have to use that expansion, that is equal to a square, that means b square, minus 2ab, that means 2p into 2, plus b square means 2 square. It is equal to, here we have p minus 0 whole thing square, so p minus 0 is p, so we have p square, plus here again 5 minus 2 is 3, so we have here 3 square. Now we square this, 3 square we get 9, plus here again p, if you square we get p square, minus this one, if you take the product, we have 2 into 2 is 4p, plus 2 if you square we get 4. It is equal to p if you square we get p square, plus 3 if you square we get 9. Now in the next line we see that on both sides of the equality, we have here 9, we have here 9. So this 9, if it comes this side, if you transfer it to one side, this is plus, it becomes minus. So therefore, not showing it, we just cancel here. This 9 and 9, they get cancel each other on both sides of the equation. Also, we have here p square, p square. These p square, they cancel each other. So we are left with minus 4p. It is equal to, now this plus 4p, if you transfer it to the right hand side, we have minus 4p. Now minus and minus, they get cancelled. 4, okay, times 4. 4, if you cancel 4, we get 1. So we have here p is equal to 1. So therefore, the value of p as required by the question is equal to 1. Now let us go to the fourth question of your exercise 7a, which says, find the value of x such that PQ is equal to QR, where the coordinates of P, Q, and R are 6, minus 1, 1, 3, and x, 8 respectively. So again, the given points are P is 6, 1, Q is 1, 3, and R is x, 8. So for PQ, your x1 is 6, your y1 is minus 1, PQ. Your x2 is 1, and your y2 is 3. For QR, means Q to R, okay, your x1 is 1, and your y1 is 3, whereas your x2 is x, and your y2 is 8. Now, according to the question as given, PQ, it is equal to QR. Now, using the distance formula here, square root of x2 minus x1 for PQ, x2 minus x1 means 1 minus 6 whole thing square plus here your y2 is 3, so y2 is 3 minus your y1 is minus 1, so 3 minus or minus 1 whole thing square, it is equal to, for QR, your x2 is x and your x1 is 1, so x minus 1 whole thing square plus your y2 is 8 minus your y1 is 3, so 8 minus 3 whole thing square. Again, if you square both sides of the equation, this radical or square root symbol will get cancelled. So we are left with whatever is inside this square root sign, that is 1 minus 6 whole thing square plus 3 minus or minus 1 whole thing square is equal to x minus 1 whole thing square plus 8 minus 3 whole thing square. Now in the next line we have 1 minus 6, it gives us minus 5, so minus 5 whole thing square plus here 3, we have two signs here, minus minus, it becomes plus, so 3 plus 1 whole thing square is equal to, again here we have x minus 1 whole thing square, which is in the form of a minus b whole thing square. So we use the expansion, I don't have to repeat that again. We have here x squared, that is a square, minus 2x into 1, that is 2ab, plus b squared, that is 1 square, plus, now here 8 minus 3 is 5, so we have here 5 squared. Next line we have minus square is plus, 5 square is 25, so we write here 25 plus, here 3 plus 1 is 4, and 4 if you square we get 16, so we write here 16 is equal to x square minus 2 into x into 1, we have 2x, plus 1 square is 1, plus 5 square is 25. Again here, on both sides of the equality, we see here there is 25, there is 25. Okay, both are of the same sign because one, if it crosses to the other, it becomes minus. So this 25 and 25, they get cancelled. We are left with x squared minus 2x plus 1. And this 16, if you transfer it this side, it becomes minus 16. So minus plus 1 and minus 16, we are left with minus 15. Since everything is transferred to one side of the equality, the other side will remain 0. Now this one here, It is a quadratic polynomial, so we factorize this by splitting the middle term. Now, we factorize this as x squared minus, since 5 into 3 is 15, whereas minus 5 plus 3x is minus 2x, so we split this middle term as minus 5x plus 3x minus 15 equal to 0. Now, between the first term and the second term, since x is common, so we take x as common, we have x minus 5 plus. And the third term and the fourth term, we have 3 as common, so we take 3 common, and then we have x minus 5 is equal to 0. Again, in the next line, we have x minus 5 and x minus 5 is common, so therefore we take out x minus 5, we are left with x plus 3, it is equal to 0. So either x minus 5 is equal to 0 or x plus 3 is equal to 0. From here we have x equal to 5, since if you transfer this to the right hand side it becomes positive 5, or x equal to, since plus 3, if you transfer the side it becomes minus 3, so x equal to minus 3. So therefore the values of x as per wanted by the question will be x equal to 5 or x equal to minus 3. So I hope you have understood these problems that we have done, and I'm giving you some home assignments, that is from exercise 7a textbook, your page 217. You will do it yourself, question number 2, question number 5, and question number 6. And after you've completed, take a photo and post it in the school WhatsApp. So that's all for today. Thank you.